circle, but if you just multiply the bottom and the top by square root of 2, you're going to see my actual question was sine alpha equals square root of 2 over 2. And sine alpha equals square root of 2 at two different places. It appears there at pi over 4 and 3 pi over 4. And I'm going to jump right into, it wants all real solutions, so we're going to do our set builder. X such that x equals, let's say, the first angle, pi over 4. Plus, you might have did 2 pi k, but I'm just going to stick with my usual 2 k pi because it's more fun that way. And then the other one is all values of x such that x equals the other angle, which is 3 pi over 4 plus 2 k pi. And you are done, and you're moving on to the next problem. Whew. Questions on this?
No.
Questions on the homework, don't say no. Because some people might. Perhaps, that's a good thing. Does anyone have questions on the homework? Does anyone want to bring up the fact that one of the answers on the answer key is completely wrong?
I didn't even look at the answer.
Yeah.
To be honest.
I'm going to be quite honest.
I did it
Today-
in class,
Okay.
and I was
I had
confident.
such confidence
Okay.
in myself that I didn't even check.
There was a mistake on the bottom left-hand corner, and it took till the beginning of today before someone realized it. So if you would have sent me an email last night, you would have got that bonus point by saying your answer key is, it was obviously wrong. Like, you could not have been like, well, maybe. It was just the bottom left-hand corner problem was so far off that it was just ridiculous. Did you guys see
I
that?
forgot we could get that extra
No.
point.
Just
Yeah.
tell you it's wrong every day.
Just every day. Mr. Pavian, that one is wrong.
Yeah, just say no.
Which one? You know, the one that's wrong.
Yeah.
But it's the bottom left-hand one that is wrong, so if you checked your answers, that one is wrong. Otherwise, if there's no questions for me, so I'm hoping either you didn't check your answers, or hopefully you didn't change that bottom left-hand one because you just copied it down. We'll see in class today when I check, because that's the one I'm actually checking.
Oh yeah, I forgot you checked the actual
Correct
You
answers.
checked one, right?
One or two, depending how long it is. When we had those long list of letters, I just memorized the order. They kind of went in. All right. So if we have no questions, then let's jump right into, boom, solving more of these. And it's kind of more of the same, just kind of with the twist. Oh, yeah. And if you look at the top, it talks about algebra. It talks about algebra. Our goal in a lot of these problems is just changing the setup of it. Just like when you had a whole bunch of x distributed on both sides of something, you'd collect all your x's, you'd put it on one side, and you'd put all your numbers on the other side. That's all we're doing. We're trying to put all of our sines, cosines, tangents on one side, and everything else on the other. So we start off with sine x minus square root of 2 equals negative sine x. And then it says find the exact solutions in the interval 0 to pi. That's much different than what it asked you yesterday. Yesterday it said find all solutions. This one says just the ones between 0 and 2 pi. So anytime you see this 0 and 2 pi, I'm not asking for set builder notation. I just want you to give me the couple angles that are on the unit circle that match this answer. Alright? So we're not doing set builder on this one, this one, this one, but on the one even lower, we are going to on the back side. Alright, so we have sine x minus square root of 2 equals negative sine x. I'm going to put all the sine x's on one side, which means I'm going to add sine x to both sides, and that will give me 2 sine x minus square root of 2 equals 0, because I just moved that negative sine x to the other side. Now I have to add square root of 2 to both sides. That will give me 2 sine x equals positive square root of 2, or just square root of 2. Finally, it's just like if you have 2x equals 4, you divide both sides by 2. Same thing here. I'm just going to divide both sides by 2 to give me that sine x equals square root of 2 over 2. Well, that's what we did for bell work. The only difference here is A, I had to solve down to here to get it, and B, there's only two places between 0 and 2 pi that actually equals square root of 2 over 2. So you're just looking at unit circle, and on your unit circle it just says x can equal pi over 4, or x could be 3 pi over 4. And like I said, this 0 to 2 pi is what tells me that I don't use set builder. I just list the couple angles that I find on the unit circle. And that's how you solve a problem like that. It's just simplifying and then finding those angles on the unit circle. Our next one says 3 tangent squared x minus 1 equals 0. Once again, we're going to collect all our terms on one side, which is our tangent squared x, and we'll put everything else on the other side. So let's go ahead and get started on that. So we're going to move that 1 to the other side. That will give me 3 times tangent squared x equals 1. Divide by 3 on both sides, which will give me tangent squared x equals 1 over 3. Once again, if I had x squared equals 1 over 3 and I want to know what x equaled, I would take the square root of both sides. So we're going to go ahead and take the square root of both sides. And that's going to tell me that tangent of x equals, what's the big thing about when I take a square root of something? What do I put in front of that square root usually?
Positive or negative?
Thank you, Maya.
Oh. I'm sorry.
Thank you, people that raised their hands and waited. Yeah, it's going to be positive or negative square root of 1 over 3. When did I move stuff?
In your sleep.
In my sleep, usually, yeah. All right, so we have positive or negative square root of 1 over 3, which we can simplify, because square root of 1 over 3 isn't on my unit circle for tangent. So we're just going to multiply the top and bottom by a square root of 3, which will give me plus or minus square root of 3 over 3. How many places is tangent square root of 3 over 3? Whether it's positive or negative? Yeah. There are actually 4 places because it is positive or negative.
Oh.
So you're actually going around the unit circle and you're coming up with every single place that tangent actually equals either a positive or a negative square root of 3 over 3. Who wants to give me one of those? Teresa. Pi over 6. Who wants to give me the next one? Yeah, Mike. 5 pi over 6. Yeah, what's the next one? 7 pi over 6. I see a theme. Can someone give me the last one? Yeah. 11 pi over 6. So this one actually has 4 answers, and it's a nice little theme because they're all over 6. So that one has 4 answers just because the square root gives me a positive or negative, right, Liam? Yeah, let's keep our head up. Okay. The next one. The next one's not too bad, but it's going to give people a little bit of fits at times because you're going to see it and you're just going to freak out, and then your mind's going to go to, let's overcomplicate this as much as possible. Cotangent cosine squared x, I could change that to 1 minus sine squared x. I could change cotangent. We're not going to do all that, all right? We're not overthinking these. We're solving them like I would in algebra, and then we apply pre-calc afterwards. So exactly what I mean by that is if I had x's and y's, I'd collect everything on one side, and I would see if I could factor it before I did anything else. So we're going to move that cotangent to the other side. So that's going to give me cotangent x cosine squared x minus cotangent x equals 0. So I just subtracted cotangent x from both sides. Now we're going to see if we can factor, yeah.
Why couldn't you just divide both sides by cotangent and get cosine equals 1?
You'd have cosine equals, well, you'd have cosine squared equals 1. I'm trying to show you an example that, I guess this probably isn't the best example because you could do that. That would be possible, but there's some that you're not going to be able to do that on. So let's go with it as is this. And in fact, it wouldn't give you all the answers.
Okay.
I'm just looking at that.
Positive and negative one.
Yeah, but it still wouldn't quite be right because we're still missing some possible answers. Because there are things I could plug in for cotangent that we're missing if we do that. And I'll show you what I mean. So if I was to factor out cotangent, we would have cotangent x times cosine squared x minus 1 equals 0. So, Mike, if we did it your way, we would just have found solutions for this one. But we'd be missing this guy over here. Because now we can use the zero product property. And the zero product property basically says if you have A times B equals 0, either A is 0 or B is 0. Or both of them can be. So either my cotangent 0 or this part is 0. So we're just going to branch it off. We're going to say, well, either cotangent x is equal to 0 or cosine squared x minus 1 equals 0. Let's do the cotangent one first. Let's do the cotangent one first because we haven't done cotangent in a while. There's two ways to look at cotangent of 0. Remember that cotangent is just the reciprocal of tangent? So you could, to figure out where cotangent equals 0, you can look at where tangent is actually undefined. The other way we can look at cotangent x, and maybe the more preferable way, is to remember that cotangent x equals cosine x over sine x. And the only way for cosine x over sine x to equal 0 is if cosine x equals 0. Because if sine x equals 0, it would be undefined. So in this case, we're actually looking for when cosine x equals 0. However you do it, you're going to see that x equals either pi over 2 or 3 pi over 2. You gotta look at your unit circle.
Oh.
Unless you're picturing in your head. But if I look up here, my cosine equals 0 up there, and my cosine equals 0 up there. And if you look at your tangents, undefines at pi over 2, and undefines at 3 pi over 2. So those are two of my solutions. And we got a few more over here, but we need to solve this. That's the part that Mike would have solved if you just divided both sides by cotangent, but you'd be missing something. Okay, so we're going to end up with cosine squared x equals 1. Take that square root of both sides, boom, boom, that gives me plus or minus 1. Cosine x equals plus or minus 1. This is a very easy one to miss maybe a half point on, because I'd only take a half point off for this. So cosine equals plus or minus 1 at 0, at pi, and here's the curveball, 2 pi. Because it says list all of them from 0 to 2 pi, including 0 and 2 pi. It will not always say that. Sometimes there will be a parenthesis here where it says do not include 0, just include the stuff from 0, including 2 pi. Or there could be a parenthesis over here saying don't include the 2 pi solution. So be careful when you read what I'm asking for. Brackets mean include it. Parentheses mean do not include it. But this one said include both of them, so we actually have 5 different solutions. Questions on this, or what I did? So try not to divide to get rid of stuff. Try to cluster everything on one side and see if you can factor. That's how these are going to work. Coo-coo-coo-coo-choo. Last one. This is the one that a majority of us might get wrong, just historically. Historically, most of the students last year lost at least a point on this one, at least a point. And it's because of that tangent 3x. Once again, our mind overcomplicates it, or sometimes you oversimplify it by dividing both sides by 3 and say, got rid of that 3. Does not work that way. You cannot just divide both sides by 3. So the hint is, we're going to write a general formula before I even deal with that 3x. The 3x is embedded in there. So the first thing we're going to do is make a general formula. And so first, we're just going to find what tangent, or not what, where tangent equals that negative square root of 3. I'm just going to figure out where tangent actually equals negative square root of 3. And who can give me the 2 places that tangent equals negative square root of 3, Caitlin?
One of them is 2 pi over 3.
2 pi over 3. Let's use degrees. So that'd be 120. Sometimes on challenging problems I just switch to degrees. Charlie?
What? Oh, the other one?
I don't know, you were raising your hand.
Yeah, I was going to say the other one.
Okay, let's say the other one.
300.
300. So now, normally I would come up with my equation because it says list all real solutions. So I'd go into set builder notation and say, x such that x equals 120 plus 360 degrees times k, correct? Are we tracking, following what I'm kind of saying? We're going to say to ourselves, I know I'm going to need a formula. It's like x equals 120 degrees plus 360 degrees times k. I know I have to create something like that. However, it's not just x here, it is 3x. So here's on the stage where that 3 actually appears. We're going to take the fact that it starts as 3x, and we're going to plug that in instead of x. Now to get x by itself, I need to divide both sides by 3. In other words, I've got to divide the whole thing by 3, which will lead us to the set builder notation, x such that x equals 120 divided by 3, which is 40 degrees, plus 120 degrees times k. And now we just have to do the exact same thing for the 300 degrees.
It's not so bad.
It's not so bad. It's easy to mess up, though. It's easy to divide 3 at the wrong stage. But we're going to have 3x equals 300 degrees plus 360 degrees, all divided by 3. That's going to equal x such that x equals 100 plus 120 degrees. Did anyone recognize that I did this harder than I needed to? Yeah, what could I have done?
They're both across from each other.
They're both across from each other. So if you don't know what I'm saying right now, just plug your ears and just go la 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 la, I get what he's doing here. Yeah?
You don't have to write 2 separate ones.
Correct. We wouldn't have to write 2 separate ones. We could have put x equals 120 plus 180k, 3x divided everything by 3, and we could have written this as one formula that would have been x equals 40 plus 180 divided by 3 would have been 60k. And 40 plus 60 would have got my 100, and then we would have kept going around and around. So we could have written as 1. If you're suave and you're just like, I got this, that'd be the way to do it. If you're just like, I just want to stick with this. That's all I want to do is just stick with the basics. Go do that. I don't want to complicate it by doing that on the first time. But just so you know, this could have been done a little simpler. Now, be aware on this one. If this was 4x, I would just put 4x and I would divide by 4. If this was x divided by 3 instead of 3x, I would just put x divided by 3, and in that case, I would multiply everything by 3 because I want to get x alone. Also be aware, so, you know, on like this problem, it had 4 different angles that could pop up. For a problem like that, you would actually have to do 4 different equations. All right, unless you could realize that some might have been 180 across from each other. All right, so it might be more than 2 of these. Could be 3, could be 4, could be 1. Who knows? Just don't overthink it, don't overcomplicate it. Collect terms, either factor, or you can go right to solving it. Questions, comments, concerns? Okay, I do have a comment for you. I don't have mine in front of me. Number 9. Number 9, and I'm hoping I remember this right. I can't find my sheet. Number 9. Can someone read number 9 to me? Is it like something equals 1? Sine squared plus sine?
Squared x plus sine of x equals 1.
Okay, that's the perfect one. So number 9, we're going to rewrite that as, and I'm going to double check here in a second. Rewrite it as sine of x times cosine of x plus sine of x equals 0. All right, cross out number 9 and replace it with that. I'm going to go ahead and see if I can find my sheet. Otherwise, you can